You're driving a car late in the night on the highway. It's kind of foggy too. You don't know where you're going, and all of a sudden, you meet with a car accident. You're rushed to the ER, and you eventually get the information that your kidney has suffered a lot of trauma, and you're desperately in need of a new kidney. Well, once you get a new kidney, you guess you'll be all right, right? But in order to get a new kidney, it will be placed on a transplant list. And it could take days, weeks, months, or even years for you to get the kidney, as it's based on priority. And if someone needs the kidney more than you, it will be directed towards them. But even if you get the kidney, will it be healthy? Well, no, because the kidney is not yours. The genes, the DNA is not yours, it's someone else's. And to prevent it from being rejected, you would have to take anti-rejection meds, which is not healthy for you. So, could you just grow the kidney in the lab? Yes. By using tissue engineering and cellular therapy, you could essentially repair or replace cells. This can combat diseases, genetic abnormalities, and severe trauma. In order for this process to work, you need three vital components: the right cell, the right supporting structure, and the right environment. So for the right cell, we would get the cell from the target organ. It could, in this case, we could get the cell from the kidney, or we could use embryonic stem cells and use them to produce kidney cells, which would then be used to produce tissue and then be part of a living organ system. For the right environment, we would require some type of biomolecule. And in this case, we would require a growth factor, which is used to, enhance the process and make the cells be more healthy and productive. And for the right supporting structure, we would require a type of scaffold, which is like a blueprint of what you're trying to produce. The scaffold can be derived from the target organ, or we could use biodegradable polymers, which keeps the cells intact and in place. This is an example of a polymer, a scaffold, and it's a gel-like structure. So to recap, we determine which cells we need to extract from the patient, and then once the cells are isolated, we group those cells together, and then we allow the sample to populate. And when that's done, we use 3D printing to print the cells into a scaffold and add growth factors and mechanical stimuli to make the tissue ready to be implanted into the patients. This is an example of a kidney being 3D printed. With this process, we can 3D print many organs, like your nose, your bladder, even cartilage. In addition to that, we can print skin grafts and a part of your lung so far. But so far, the most innovative disruption that's taken place is the production of a full trachea. Some other species can produce their limbs, eyes, and even, the entire body. This is a flatworm, which can, once it's chopped in pieces, it can just regrow, and that's insane. If we make more progress in regenerative medicine, there's a lot of room for growth, and eventually we can just grow or produce anything whenever we want. One company working on a disruption is Biofuel 4D, which is working on a venture to, produce or 3D print living hearts to combat heart diseases. With regenerative medicine constantly being developed on and the constant innovations been working on, we can hope for more and sustainable future in regenerative medicine. Thank you.